You're tuning into the deep dive because you want to cut through the noise and really understand something without getting totally bogged down in jargon. Today, we're tackling software testing metrics.
Hmm.
Think of this as your fast track to understanding how we measure the quality of software and maybe more importantly, how we make it better.
Yeah, exactly.
We've got some pretty insightful material here, and our mission is simple. Just extract the essential knowledge about what these metrics are, the different types, and how they're actually used to improve, both the software itself and the testing process.
That's right. It's really about moving beyond just saying, oh, we tested it, to having actual concrete numbers that tell a story.
Hmm.
A story about the software's health and the effectiveness of our testing efforts.
Okay.
So let's dive straight into the core question. What exactly are software testing metrics?
Well, put simply, based on our sources, they're quantitative measures, basically. Numbers that give us a way to gauge the progress of testing, the quality we're achieving, how productive the team is, and even the overall health of the testing process.
Right.
The big picture goal here is really to make testing more efficient and effective, and to give us solid data to, inform our decisions.
And our source uses a really useful analogy, actually, to illustrate this. Think about your car. You might look at your weekly mileage compared to, say, the manufacturer's recommendations.
Mm-hmm.
That's a metric in action. It gives you a sense of how you're using your car relative to those expectations. Software testing metrics, well, they do the same thing for our testing activities.
And here's a fundamental principle that really resonated from the source. We cannot improve what we cannot measure.
That's key.
It's such a straightforward idea, but it really underscores why these metrics are so vital. They're not just about, collecting data. They're the bedrock for making actual meaningful improvements.
Definitely.
Our source also highlights some key reasons why they're important. They help us decide what our next steps should be. They give us evidence to back up our claims or predictions. They pinpoint exactly where we need to get better, and they inform those critical decisions about our processes and maybe even the technologies we use.
Precisely.
Mhm.
Without these metrics, we're essentially flying blind, aren't we? We might have a gut feeling that testing is going well, but we lack the concrete evidence to either confirm that or, crucially, to identify potential problems before they really escalate.
Okay, so we know what they are and why they're crucial. Now, let's maybe break down the different categories of test metrics. Our source outlines three main types. First up are process metrics. What's the focus there?
Right. Process metrics are all about the software development lifecycle itself,
Hmm.
the SDLC, which is, essentially the roadmap for how software gets built.
Mm-hmm.
These metrics help us evaluate how efficiently that entire process is operating and pinpoint areas where we can maybe streamline things, speed them up a bit.
That makes perfect sense. Then we have product metrics. This sounds like it's directly connected to the quality of the software we're actually building, right?
Exactly. Product metrics deal with the inherent quality of the software itself. Think about things like the number of bugs we're finding, how reliable the software is proving to be in testing, and how well it actually aligns with the initial requirements.
Gotcha. And the third category is project metrics. What kind of insights do these give us?
So project metrics take a look at the team responsible for the testing and also the tools they're using. They help us assess the efficiency of the project team, like are they being as productive as they could be?
Mm.
And are our testing tools actually helping us, or are they maybe creating unnecessary hurdles?
So we've got these three main buckets: process, product, and project. But I mean, just throwing a bunch of metrics at a project isn't a silver bullet, surely. Our source really emphasizes that choosing the right metrics is critical.
Oh, absolutely.
What factors should we be considering when making those choices?
That's a really insightful question, actually. The source lays out some key considerations. First, you need to clearly identify your target audience for these metrics. Who are you actually sharing this information with? Because different stakeholders will naturally have different priorities, different interests.
Right.
Then you need a crystal clear definition of the goal for each metric. What specific question are you trying to answer? What actionable insights are you hoping to get out of it?
That makes total sense. I mean, if you're talking to the development team, they'd probably be most interested in metrics about the defects being found, right?
Mhm.
Whereas a project manager might be more focused on the big picture, like progress and sticking to the schedule.
Precisely. And our source also stresses the importance of introducing all relevant metrics based on the specific needs of the project you're working on. Don't just pick metrics because they're, commonly used. Make sure they actually provide valuable, meaningful information for your particular situation. And finally, there's the crucial cost-benefit analysis. Collecting and rigorously analyzing metrics takes time and effort, right? So you need to carefully consider whether the insights you gain are truly worth that investment. And you also need to think about which stage of the project lifecycle will give you the most bang for your buck from tracking certain metrics.
Okay, that's useful. Let's zoom in now on manual test metrics specifically. The source breaks these down into two key types, base metrics and calculated metrics. Can you walk us through the distinction?
Sure. So base metrics represent the raw, sort of unprocessed data points that are directly collected by the test analysts during the core activities, like test case development and execution.
Okay.
Think of fundamental counts, like just the total number of test cases written or the number of test cases actually run. It's the initial unanalyzed stuff.
And then calculated metrics are derived from that raw data. Is that it? They're the ones that give us a more synthesized, maybe easier to understand overview.
Exactly. Calculated metrics take those base metrics and transform them into something more informative, more readily usable for reporting and analysis. For instance, if you take the number of test cases executed, a base metric, and divide it by the total number written in another base metric, you get the percentage of testing that's complete. That's a calculated metric.
Right.
Test managers often rely heavily on these calculated metrics for their progress reports and such.
Okay. Our source also gives us a list of some important metrics that might be particularly relevant depending on the specific project or, say, the business model. Could you share a few examples of those?
Absolutely. We see things like test case execution productivity, which measures how many test cases are being run within a certain time frame.
Mm-hmm.
Similarly, there's test case preparation productivity. Then, of course, defect-related metrics are always critical. This includes, the total number of defects found, how those defects break down by priority and severity, and the defect slippage ratio.
Defect slippage ratio. What exactly does that track?
Good question. Defect slippage measures the percentage of defects that were missed in one testing phase and only found later, perhaps by the customer after release, which is obviously not ideal.
Oh, right. So a high slippage isn't just about finding bugs late.
Exactly. It likely points to more systemic issues earlier in the development life cycle, maybe problems in requirements gathering, or perhaps the early testing phases weren't thorough enough.
Yeah, defect slippage definitely sounds like something you'd want to keep a really close eye on. Finding a critical bug right before release is way more disruptive and costly than catching it early on. It's like the bugs are sneaking through the net.
You're spot on. Now, our source also guides us through the test metrics life cycle in software engineering. It's not quite as simple as just picking a metric and calculating it once. There's a whole process involved. Could you maybe outline the key stages in this life cycle for us?
Sure thing. The initial stage is analysis. This is where we figure out which specific metrics are actually needed and then define them very precisely. We need to have a super clear understanding of what each metric represents and exactly how it's going to be measured and tracked.
Right, clarity is key there. And following analysis is communication. This is absolutely vital for getting buy-in and just making sure everyone's on the same page.
Makes sense.
You need to clearly explain to both the stakeholders and the testing team the reasons why these particular metrics are important. And crucially, you need to thoroughly educate the team on precisely what data points they need to capture and the correct methods for doing that accurately.
Yeah, I can see that. If the team doesn't really get why they're tracking something, or if they're not sure how to collect the data correctly, then the metrics you get out are basically useless, right?
Pretty much. Garbage in, garbage out, as they say.
So what's the next step after communication?
The next stage is evaluation. This is where the actual work happens. The necessary data gets collected, it's rigorously verified, you have to make sure it's accurate and complete, and then the actual values for the chosen metrics are calculated based on this validated data.
Okay, collection, verification, calculation, and the final stage in this cycle is report, I assume.
That's it, report. This is where we take those calculated metric values and compile them into a clear, concise report. Our source emphasizes that this report needs to have an effective conclusion, meaning it shouldn't just be a dump of numbers.
Right.
It should provide insightful analysis and, ideally, actionable interpretations. This report is then distributed to all the relevant stakeholders, and importantly, our source highlights the value of actively seeking feedback on the report itself.
Oh, the feedback loop. That's smart.
That feedback loop is absolutely key. Are the metrics we're tracking actually providing the insights people need? Is the report easy to understand? Gathering and acting on that feedback helps us refine and improve the entire metrics process over time. It's iterative.
Okay, now, let's get down to brass tacks. Our source provides a really practical example of how to calculate a test metric, focusing on that crucial area of testing progress tracking. Can you walk us through the steps in that example?
Absolutely. So the very first step, step one, is to clearly identify the key process you want to measure. In this specific example, the focus is on testing progress tracking. Simple enough.
Right.
Step two involves using baseline data to define your target metric. Here, the baseline is established as the planned number of test cases to be executed each day. This gives us a clear benchmark, something to measure against.
Okay, so we've set our target. What's the third step?
Step three involves deciding the frequency, how often are you going to track this? And just as important, clearly assigning responsibility for the tracking. In this example, the actual number of test cases executed each day is recorded by the test manager daily. This ensures consistency and timely data collection.
Got it. And then we move on to step 4, the actual calculation and, crucially, the interpretation.
Exactly. The test manager calculates the actual number of test cases executed each day. But like we said, just having the number isn't enough. The vital part is the interpretation. Are we hitting our target, falling behind, maybe even exceeding it? What do these numbers actually tell us about our progress?
And the final step, step 5, is all about taking action based on those insights, isn't it? What do we do with this information?
Precisely. Step 5 is about identifying specific areas where improvements might be needed based on how you interpreted the data. For instance, if the actual rate of test execution is consistently lower than planned, well, you need to investigate why. Are there unexpected roadblocks? Are the test cases maybe more complex than anticipated? Based on that investigation, you can then propose and implement targeted improvements to get things back on track.
Okay, that makes sense. Our source also gives us a specific formula for calculating the percentage of test cases executed. Can you share that formula?
Certainly. It's quite straightforward. You take the number of test cases executed divided by the total number of test cases written, and then multiply that by 100.
Simple percentage.
Yep. Gives you a clear percentage showing how much of your planned testing is done. And the source also points out you can use similar calculations for other things, like the percentage not executed, the percentage passed, failed, blocked, and so on.
Right, useful variations. Now, to really cement our understanding, our source includes a very helpful test metrics glossary. It lists key terms and their formulas. Let's maybe dig into a few of these to get a clearer picture. First up, rework effort ratio. What's that tell us?
Okay, the rework effort ratio. The formula is actual rework effort spent in a phase divided by the total actual effort spent in that phase, times 100. Essentially, it tells you what percentage of effort within a specific development phase had to be spent fixing mistakes or redoing work.
Ah, okay.
A high rework ratio in, say, the coding phase could indicate maybe issues with requirements clarity or maybe coding standards weren't followed, that sort of thing.
That's definitely a metric you'd want to see going down. What about requirement creep? Sounds like scope changes.
It is indeed. Requirement creep is calculated as total number of requirements added divided by the number of initial requirements times 100. This just quantifies how much the project scope has expanded since you first defined it. Significant creep can really mess with timelines, resources, and just overall project stability.
Yeah, I bet. Another one listed is schedule variance. Seems pretty self-explanatory.
Schedule variance is quite direct, yes. It's simply the difference between the actual finish date of something, a task, a deliverable, the whole project, and the original planned date for that same thing. Positive variance means you're late. Negative means you're early.
Okay. Here's an interesting one. Cost of finding a defect in testing. How's that calculated and why track it?
Good one. The cost of finding a defect in testing is calculated as total effort spent on testing divided by the total number of defects found during testing. This gives you insight into the efficiency of your testing efforts. Generally, a lower cost per defect found suggests your testing processes are more effective at uncovering issues with the resources you have. It's about bang for your buck in testing.
We also have schedule slippage. Is that basically the same as schedule variance?
Close, but schedule slippage offers a slightly different angle. It's calculated as actual end date, estimated end date, divided by planned end date, planned start date, then times 100.
Okay.
This gives you a percentage representing how much the project's overall end date has slipped relative to the originally planned duration of the project. It contextualizes the delay against the project length.
Ah, I see the difference. Let's shift to some more direct test outcome metrics like passed test cases percentage, failed test cases percentage, and blocked test cases percentage. The formulas seem pretty intuitive here.
They are quite direct, yeah. Passed test cases percentage is simply number of passed tests Total number of tests executed times 100.
Mhm.
And similarly, for failed or blocked, you just swap past tests in the numerator with the count of failed or blocked tests, respectively. These percentages give you a quick, clear snapshot of the current software quality under test and highlight areas needing attention.
Then we have metrics focused on the defects themselves. Fixed defects percentage, accepted defects percentage, and defects deferred percentage.
Right. Fixed defects percentage is number of defects, fixed total number of defects reported times 100. Shows how many reported issues have actually been resolved.
Okay.
Accepted defects percentage is number of defects accepted as valid by total defects reported times 100. This helps gauge the quality of the bug reports themselves. Are they valid issues?
Makes sense.
And defects deferred percentage is number of defects deferred for future releases, total defects reported times 100. This shows the proportion of known issues being pushed out to later releases.
There's also critical defects percentage, and that sounds particularly important.
Absolutely critical, you could say. Critical defects percentage is calculated as number of critical defects, total defects reported times 100. It gives you a clear view of the severity of the issues you're finding. A consistently high percentage of critical bugs. That's a huge red flag needing immediate attention.
Definitely. And what about the average time for a development team to repair defects? How is that calculated and why is it valuable?
This one is total time taken for bug fixes divided by the total number of bugs fixed.
Yeah.
It helps assess how responsive and efficient the development team is at actually fixing the bugs reported.
So turnaround time.
Exactly. A shorter average repair time generally indicates a more efficient, maybe more agile development process for handling defects.
Okay. We also have metrics looking at the efficiency of testing activities, like number of tests run per time period, test design efficiency, and test review efficiency.
Right, measuring the testers themselves in a way. Number of tests run per time period is just total number of tests run, total time spent testing, measures throughput. Test design efficiency is number of tests designed, total time spent on test design, indicating how quickly test cases are being created. And test review efficiency is number of tests reviewed, total time spent on test review, showing the speed and effectiveness of the review process for those test cases.
And finally, we have the bug find rate, sometimes called the number of defects per test hour.
Yep, that's calculated as total number of defects found, total number of test hours expended. It's another key measure of testing effectiveness. How many defects are we uncovering for the effort we're putting in?
Wow, that's a really comprehensive overview. It truly illustrates the sheer number of different aspects of the software testing process and the resulting software quality that we can actually measure and track.
It is, isn't it? And it really underscores that critical point we discussed earlier.
Yeah.
You have to carefully select the right metrics, the ones most relevant to your specific context and goals. That's absolutely essential if you want to gain meaningful, actionable insights.
So as we kind of wrap up this deep dive, it seems clear that software testing metrics are way more than just abstract numbers on a spreadsheet.
Definitely not.
They provide crucial, quantifiable insights into how effective our testing efforts are and the overall quality of the software we're actually building. By understanding and using these metrics intelligently, we can make much better, data-driven decisions and continuously strive for improvement all through the software development lifecycle.
Exactly. And for you, our listener, whether you're, prepping for an important meeting, just trying to get a solid grasp of this vital field, or maybe you're just curious, this deep dive should give you a strong foundation, an understanding of how software quality is objectively measured and continuously improved.
Yeah.
It's a valuable perspective to have, really, regardless of your specific role, even if you're outside of tech.
Absolutely. And on that note, here's maybe a final thought to chew on. We've explored pretty thoroughly how applying measurement principles is essential in software testing. But think about this. How might similar data-driven quantitative approaches be valuable in other areas? Maybe in your own projects or workflows completely outside technology.
Interesting question.
What specific aspects of your own work or even personal projects could potentially benefit from a more structured, data-informed approach to tracking progress and ensuring quality? Just something to ponder. Thanks for joining us for this deep dive.